Welcome to the course on Python for data analytics, machine learning, and generative AI. In this video, we are going to learn about dictionary in Python, an essential guide to write expressive Python code. In this video, we will cover dictionary basics, core properties of dictionaries, creating and accessing dictionaries, essential dictionary methods, dictionary comprehension, conditional logic in dictionary comprehension, nested dictionaries, and best practices and readability. By the end of this course, you will understand to create and transform dictionaries in a clean, readable way. Instead of writing long loops and multiple lines of code, you will learn how to express complex transformations in a single elegant statement. Python dictionaries are a built-in versatile data structure used to store data in key value pairs. They are highly efficient for data retrieval, insertion, and deletion, performing these operations in constant time because they use a hash table internally. First, we will establish the core concept by understanding what is dictionary and why they matter. Next, we will build a strong foundation by creating dictionaries using traditional for loops. This ensures you understand what's happening behind the scenes. Once that's clear, we move to the better way, dictionary comprehension, where you will see how Python simplifies common patterns. Finally, we will reach advanced mastery applying conditions, transformations, and nested structure. What is a Python dictionary? A Python dictionary is a data structure that stores information as key value pairs. Think of it like a real world dictionary. You look up a word, the key to find its meaning, the value. Unlike list, dictionaries don't use numerical positions or indexes. Instead, data is accessed directly through meaningful keys. Technically, Python dictionaries are mutable, ordered collections that do not allow duplicate keys. This makes them ideal for representing real-world relationships such as names and ages, product IDs and prices, or configuration settings. Understanding this concept is essential because dictionary comprehension builds directly on how dictionaries store and retrieve data. Once you are comfortable with keys and values, everything else becomes much easier. First, we initialize a dictionary using curly braces and key value pairs. Then we add a new item by assigning a value to a new key. Accessing data is done using the key inside square brackets, not an index, like which we have in list. An important takeaway is the key error. If you try to access a dictionary using a number or a key that doesn't exist, Python raises an error. This reinforces the idea that dictionaries are key-based, not position-based. These fundamentals are critical because dictionary comprehension will automate the same operations just in a more compact and expressive form. Let's now see the core properties of dictionaries. First property is flexible data types. Values can be integers, strings, list, or even other dictionaries. Second, dictionaries are mutable, which means you can add, modify, or delete entries after creation. Third, keys must be unique. If a key appears more than once, the last value overrides the earlier one. Finally, dictionaries are ordered as of Python 3.7 version, which means items maintain their insertion order. These properties explain why dictionaries are so powerful and why dictionary comprehension is such a valuable tool for transforming structured data efficiently. Let's now see how to access dictionary components. Before building a dictionary comprehension, you need to know how to access dictionary contents. Python provides three key methods: key of, value of, and items of, while keys of returns all keys and values of returns all values. Items of returns key value pairs together. The items of method is especially important. It's the most common foundation for dictionary comprehension. It allows you to loop through both keys and values simultaneously, making transformation simple and intuitive. Understanding the steps ensures that dictionary comprehension doesn't feel like magic. It's simply a concise way to loop through dictionary items. Let's now solve the traditional approach using a for loop. We want to create a dictionary where the keys are even numbers and the values are their squares. To do this, we initialize an empty dictionary, loop through numbers, apply a condition, and assign values step by step. This approach works perfectly and is easy to understand. However, it requires multiple lines of code to express a single logical transformation. This example sets the stage for dictionary comprehension by showing what we are trying to improve: clarity, consciousness, and expressiveness. Now let's solve the same problem using dictionary comprehension. In a single line, we loop through numbers, apply a condition, and generate key value pairs. The result is identical, but the code is shorter, clearer, and more expressive. This is the essence of Pythonic code, saying more with less. Dictionary comprehension shines when you want to transform data in a clean and readable way. As you practice, you will find that many loops you once wrote can be replaced with comprehensions. Anatomy of a dictionary comprehension breaks down the structure of a dictionary. The curly braces creates the dictionary. The key:value expression defines what each entry looks like. The for class iterates over the source data, usually using .items of. Optional conditions can filter which items are included. Once you understand this anatomy, you can read and write dictionary comprehensions with confidence. Every part has a clear purpose and nothing is hidden. Let's now learn how to make dictionary comprehensions more powerful using conditions. Sometimes we do not want to include all items from a dictionary, or we may want to change values based on a rule. There are two main ways to use conditions. First, filtering with if. Here, the condition decides which items are included. If the condition is true, the item stays. If it is false, the item is removed. Second, transforming with if-else. Here, all items are included, but values are changed based on a condition. The flow diagram shows this clearly. We start with an input dictionary, apply a condition, and then either filter it with if statement or transform values using if-else. Let's see how filtering uses if in dictionary comprehensions. The key rule is important. The if condition is placed at the end of the comprehension. Let's start with the dictionary containing letters and numbers. The goal is to keep only values greater than 2. Using if v greater than 2, Python checks each value. Only matching items are included in the new dictionary. That is why the output contains only C, D, and E. Now we apply two conditions: value greater than 2 and value divisible by 2. Notice, we use two if statements, one after the other. Multiple if conditions work like an AND condition. Only D:4 satisfies both rules. Now let us learn how to transform values using if-else. Here is the most important rule. If else is placed at the beginning inside the value part. Let's classify numbers as even or odd. We loop through the dictionary items as usual. For each value, if it is divisible by 2, we assign even, otherwise we assign odd. Notice that no items are removed. Only the value changes, not the keys. The output dictionary clearly shows odd for 1, 3 and 5, even for 2, 4 and 6. Now let's see nested dictionary. A nested dictionary means dictionary inside another dictionary. Let's see an example for nested comprehension. The goal is to convert inner values to floats. The comprehension uses one loop for the outer dictionary, another loop for the inner dictionary. This works, but the code becomes harder to read. Readable alternatives. On the right side, we see the same logic using standard loops. First, we loop through the outer dictionary. Then, we loop through the inner dictionary. Finally, we update values using float of. The result is the same, but the code is clearer, easier to understand. Let us quickly understand important dictionary methods. Items of returns key value pairs. Keys of returns all keys. Values of returns all values. Get key safely gets a value. Update of adds or modifies items. Pop key of removes a specific key. Pop item of removes the last item. From keys of creates a dictionary from keys. Copy of makes a shallow copy. Clear of removes everything. These methods are essential tools when working with dictionary. Let's now have a quick summary on what we have covered in Python data type dictionary. Dictionary stores data as key value pairs, where each key is unique and immutable. They are changeable, maintain insertion orders from Python 3.7 version onwards, and do not allow duplicate keys. We can easily create, access, add and delete dictionary entries. Common access methods, which includes key of for all the keys, value of for all values, items of for key value pairs. Dictionary comprehension is a powerful and concise way to create dictionaries. Comprehensions allow us to build new dictionaries in one line, making code shorter and more readable compared to traditional for loops. They also support conditional logic, if for filtering items and if else for transforming values. So, let's open Jupyter Notebook and write some Python code on dictionaries together and bring the concept of Python dictionary to practice. Thank you.